March 2026. The night sky looked ordinary. At first, cities buzzed with their usual noise. Traffic lights blinked over crowded streets. People scrolled through their phones, unaware that above them something ancient was beginning to unfold. Then slowly, almost silently, the moon began to change. A shadow crept across its surface. Minute by minute, the bright silver glow faded. And then it happened. The moon turned red, not orange, not pink, a deep, haunting crimson, the color of burning embers in a dying fire. Across the world, millions of people stopped what they were doing. Phones lifted toward the sky. Live streams started instantly. Social media exploded with the same message. Look at the moon. For most people, it was simply a beautiful cosmic moment, a rare astronomical event known as a blood moon, when the Earth moves perfectly between the sun and the moon, casting a shadow that filters sunlight through our atmosphere, a natural phenomenon, predictable, harmless. Or at least, that's what it appears to be. Because while millions admire the spectacle, a much smaller group watches the clock. Scientists, space agencies, geophysical observatories, even military monitoring stations, not because of the eclipse itself, but because of what comes after. For decades, researchers studying planetary systems have quietly noticed something strange. The real mystery doesn't happen during the blood moon. It happens in the 72 hours that follow. Subtle shifts begin moving through Earth's systems, tiny changes in atmospheric pressure, unusual fluctuations in the planet's magnetic field, animals behaving strangely, migrating earlier, going silent, or moving in unexpected directions. Even human sleep patterns begin to shift. Most people never notice these changes, but instruments do. Satellites detect them. And those who study the planet carefully know that during these 72 hours, Earth enters a brief but mysterious window, a period where small disturbances can ripple outward into much larger consequences. Sometimes nothing happens, but sometimes history moves. Earthquakes, sudden geopolitical tensions, financial shocks, solar disturbances from deep space, events that seem unrelated, yet they appear again and again in the days immediately following major lunar alignments. Coincidence? Maybe. But patterns have a strange way of repeating when no one is paying attention. And tonight, as the blood moon fades and the sky slowly returns to darkness, the countdown begins again. 72 hours, 3 days. A small window of time where the planet quietly adjusts itself after a rare cosmic alignment. Most people will sleep through it. Most will never even know it's happening. But to understand why those hours matter, we have to go back to the last time the moon turned red, because what followed that eclipse caught the entire world completely off guard. The moment the eclipse ends, everything seems normal. The red shadow slowly slides off the moon's surface. That eerie crimson glow fades away. Minute by minute, the moon returns to its familiar silver light. The same quiet companion humanity has watched for thousands of years. People take their final photos, live streams end, comments fade from social media feeds, and across the planet, millions of people go back to their normal lives. Some go to bed, others return to work. Cities settle into the rhythm of another ordinary night. From the ground, nothing seems different. The sky looks calm again. The moon looks normal again. The event feels finished. But deep inside Earth's systems, the real story is only beginning, because a lunar eclipse is more than a beautiful shadow across the sky. For a brief moment, something rare happens in the architecture of our solar system. The sun, Earth, and moon align almost perfectly in a straight line. Astronomers call this alignment syzygy, a precise cosmic arrangement where gravitational forces temporarily pull in the same direction. For most celestial bodies, this kind of alignment happens all the time. But on Earth, where oceans, atmosphere, and magnetic fields interact in a delicate balance, Even a small shift in gravitational influence can ripple through multiple systems at once. During the eclipse itself, the effects are subtle, but when the alignment ends, Earth begins to rebalance. Researchers who study planetary dynamics sometimes refer to the first 24 hours after a major lunar eclipse as something quietly fascinating, the adjustment window. It's not an official scientific term you'll see in textbooks, but among observatories and satellite monitoring teams, the phrase has been used to describe the short period where Earth's interconnected systems settle back into equilibrium. Think of it like a massive machine. When every part lines up perfectly for a moment, even slightly, tension builds across the entire structure. And when the EU alignment breaks, the system relaxes. But relaxation isn't always smooth. Sometimes it comes with small jolts, subtle shifts, tiny corrections spreading across the planet. One of the first places scientists see these changes is in the oceans. Earth's tides are controlled primarily by the gravitational pull of the moon and the sun. During a lunar eclipse, when Earth sits directly between them, their gravitational forces briefly interact in a unique configuration. The result? Slight variations in tidal behavior. Not massive waves crashing into coastlines, but measurable differences. Ocean monitoring buoys sometimes record tides arriving minutes earlier or later than expected. Currents shift slightly. Pressure patterns in the deep ocean adjust. These changes are tiny, far too small for a person standing on a beach to notice, but satellites and sensors can detect them, and oceans are only the beginning. High above the surface, another invisible system begins adjusting, Earth's magnetosphere. Our planet is surrounded by a massive magnetic field generated by the movement of molten metal in its core. This magnetic shield protects us from solar radiation and cosmic particles streaming through space. Most of the time, the magnetosphere behaves like a stable bubble surrounding the planet, but it's also incredibly sensitive. Solar wind pressure, atmospheric currents, and gravitational interactions can all influence its shape and behavior. During alignment events like a lunar eclipse, scientists have occasionally observed small fluctuations in magnetic activity. Changes in the way charged particles move through the upper atmosphere, shifts in the way Earth's magnetic field stretches and contracts in response to space weather. Again, these changes are small, but they're real enough for satellites to notice. And when multiple planetary systems begin adjusting at the same time, something interesting happens. Patterns emerge. Another group that seems to notice these subtle shifts long before humans do is animals. Throughout history, wildlife has displayed strange behaviors around celestial events. Birds altering migration timing, marine animals changing swimming routes, nocturnal creatures suddenly becoming restless. Even domestic animals sometimes appear unusually alert or agitated. Scientists debate the reasons behind this. Some believe animals are sensitive to small magnetic changes. Others think it's related to variations in nighttime brightness or atmospheric pressure. But whatever the cause, patterns exist, and they often appear during the hours following lunar events. Still, none of this means something dramatic will happen. Most of the time, the adjustment window passes quietly. Earth systems stabilize. The oceans settle. Magnetic fluctuations smooth out. Wildlife returns to normal behavior. The world continues spinning exactly as it always has. But occasionally, the adjustment isn't smooth. Because Earth isn't a simple machine. It's a network of interconnected systems. The atmosphere influences the oceans. The oceans influence climate patterns. Climate patterns influence pressure systems. Pressure systems influence geological stress. Everything affects everything else. So when small shifts ripple across multiple systems at once, sometimes those ripples intersect. And when they intersect at the wrong moment, they can amplify each other. Scientists call this phenomenon cascade effects, a small trigger that pushes a system already close to instability. Imagine a stack of dominoes. Most of the time, they remain standing. But if the structure is already under tension, one tiny push can send the entire line collapsing. Planetary systems can behave the same way, not often, but often enough to make researchers pay attention. There have been moments in modern history when unexpected events occurred shortly after celestial alignments. A sudden earthquake along a fault line already under pressure. A powerful storm forming faster than predicted. A chain reaction of financial panic triggered by small market shifts. None of these events are directly caused by the moon. Science doesn't support that idea, but timing can still matter. Because if a system is already near its breaking point, even the smallest change in stress can be the moment that pushes it over the edge. That's what makes the adjustment window so fascinating. It's not about the eclipse itself. It's about the conditions immediately afterward. A brief period where Earth's delicate balance shifts ever so slightly before returning to normal. And in a world already full of tension, geological tension, climate tension, political tension, economic tension, even small disturbances can have unpredictable consequences. Most of the time, nothing happens. But sometimes, the planet doesn't settle quietly. Sometimes the adjustments ripple outward into the next phase. Because if the first 24 hours are about Earth attempting to stabilize, the next stage is about what happens when stability doesn't come fast enough. And that brings us to the most unpredictable moment in the entire cycle, the 48-hour shift. The point where small adjustments can begin turning into something far more serious. Around 48 hours after the eclipse, something curious tends to happen. Not something obvious, not something dramatic enough to make headlines immediately, but something noticeable. At first, it appears as small disturbances. Weather models begin behaving strangely. Ocean sensors record unusual movement patterns. Magnetic readings show brief fluctuations. Nothing alarming, just different. To the average person, the world still feels completely normal. But for scientists watching Earth through satellites and monitoring networks, the second day after a lunar eclipse is often the moment when subtle changes begin forming patterns. It's the moment when the planet stops adjusting and begins reacting. This phase is sometimes described by researchers as a period of redistribution. The gravitational alignment that occurred during the eclipse has already passed. The Sun, Earth, and Moon are no longer perfectly lined up, but the systems that were temporarily pulled into alignment are still settling. Imagine stretching a giant web of tension cables across an entire planet. For a moment, those cables were pulled slightly tighter in one direction. When that force releases, the tension doesn't disappear instantly. It shifts, slowly, sometimes unpredictably, and occasionally, violently. Around the 48-hour mark, researchers studying long-term environmental patterns have noticed that disturbances across multiple systems can begin appearing at the same time. Storm systems that were expected to weaken suddenly intensify. Atmospheric pressure changes more rapidly than predicted. Jet stream patterns wobble slightly out of their usual paths. Again, these changes are subtle, but the atmosphere is an incredibly sensitive system. Small changes in pressure or temperature can influence how storms form and how they travel across continents. Meteorologists sometimes notice these unusual behaviors in weather data long before the public ever hears about them. A storm that forms faster than expected, a pressure system that stalls longer than predicted, a cyclone that shifts course suddenly. Most of the time, these irregularities resolve themselves, but occasionally they grow. And while the atmosphere is adjusting, another system beneath our feet may also be shifting. The Earth's crust. Our planet's surface is not a single solid shell. It is divided into massive tectonic plates slowly moving across the planet's mantle. Most of the time, those plates slide so slowly that humans barely notice their motion. But deep along fault lines, enormous pressure builds over years, decades, even centuries. When that pressure finally releases, we call it an earthquake. Now here's something interesting. Some geophysicists have studied correlations between lunar cycles and seismic activity. Not because the moon directly causes earthquakes, but because the moon's gravity influences tidal forces inside Earth's crust, just like it influences the oceans. These are called earth tides. tiny flexing motions in the planet's crust caused by gravitational pull. Most of the time, these forces are far too weak to trigger anything significant. But if a fault line is already under extreme stress, even a slight change in gravitational tension could potentially act as the final nudge. Again, scientists remain cautious about making direct claims. Earthquakes are incredibly complex events influenced by countless geological factors. But researchers have noticed something worth studying. Some seismic events appear slightly more common during periods of strong lunar alignment. Not dramatically more common, but enough to keep scientists curious. And the 48-hour window after a lunar eclipse often falls right within that period of shifting gravitational tension. Still, storms and seismic patterns are only part of the story, because the most unpredictable reactions during this phase may not be geological at all. They may be human. History shows that moments of uncertainty in the natural world often ripple into human systems. Markets respond to rumors. Investors react to fear. Small signals can trigger large reactions. Financial markets, for example, are extremely sensitive to perception. If enough traders believe instability is coming, their actions can create the very instability they fear. Sudden sell-offs, rapid market corrections, unexpected volatility. These shifts don't require cosmic events to occur. They happen regularly. But during periods when the world already feels uncertain, when people are already paying attention to strange natural events, the psychology of crowds can change quickly. Fear spreads faster than facts. And once fear spreads, systems move faster than anyone expects. Geopolitical tensions can behave the same way. A small misunderstanding between nations, a military exercise interpreted as a threat, a sudden resource shortage. In calm times, these issues are handled slowly through diplomacy. But during moments of heightened tension, decisions can escalate quickly. And this is where the delayed reveal strategy comes into play. Because the real question isn't whether the moon causes these events. It doesn't. The universe is far more complicated than that. But the deeper question is this: why do certain global disruptions seem to cluster around moments when multiple systems, natural and human, are already under pressure? The answer may be surprisingly simple. When several systems are already near their limits, timing matters. Imagine balancing a pencil upright on your fingertip. For a moment it can stay perfectly still, but the longer it balances, the more sensitive it becomes to even the smallest movement. A tiny vibration, a faint breeze, a small shift in your hand. And suddenly, the pencil falls, not because the vibration was powerful, but because the system was already unstable. Earth can behave in a similar way. Our planet is constantly balancing enormous forces, atmospheric pressure systems, ocean currents, tectonic stress along fault lines, solar radiation interacting with the magnetosphere, human societies managing economic, political, and technological pressures. Most of the time, these systems remain stable, but when several of them approach their limits simultaneously, small disturbances can cascade through the network. That's why the 48-hour shift is so fascinating. It's the moment when the planet's adjustment period overlaps with existing global tensions. A brief window where environmental systems, technological systems, and human systems all become slightly more sensitive. Most of the time, nothing extraordinary happens. The planet stabilizes, storms weaken, seismic pressure holds. Markets calm down. Life continues exactly as it did before the eclipse. But sometimes, that stabilization takes longer. Sometimes the tension continues building, and when that happens, the final phase begins. Because if the first 24 hours are about adjustment, and the next 24 hours are about redistribution, then the final stage is something entirely different. It's the moment when the planet decides whether to settle peacefully, or release the remaining tension all at once. The last 24 hours, the most unpredictable part of the entire cycle. By the time the third day arrives, the sky looks completely normal again. The moon has returned to its familiar silver glow. The red shadow is long gone. Most people have already forgotten the eclipse happened. News cycles have moved on. Social media is filled with new trends. The blood moon has become just another memory in a long timeline of celestial events. But deep inside Earth's systems, the final stage of the cycle is approaching. Researchers who study planetary behavior sometimes describe this moment with a quiet phrase: the release phase. The final 72nd hour after the eclipse. This is the moment when the planet finishes adjusting to the alignment that briefly occurred between the Sun, Earth, and Moon. By now, the gravitational tension has shifted. Atmospheric pressure patterns have settled. Ocean systems have redistributed their energy. Magnetic fluctuations begin returning to their usual patterns. In most cases, this is the moment when everything stabilizes. The system relaxes. Balance returns. The planet exhales. But sometimes, release doesn't come smoothly. Sometimes pressure that has been building across multiple systems reaches a tipping point, and when that happens, the release can be sudden. A storm intensifies faster than predicted. A fault line finally shifts after years of silent stress. A market reacts sharply to uncertainty. A political conflict escalates faster than anyone expected. To observers looking at a single event, these moments appear unrelated, random, unpredictable. But when researchers analyze long timelines of planetary activity, they sometimes notice something fascinating. Moments of instability often occur during windows when multiple systems are already adjusting at the same time. And that brings us to the twist very few people talk about, because the most powerful force during those 72 hours may not be geological at all. It may be psychological. For centuries, humans have noticed strange connections between lunar cycles and human behavior. Stories about the moon influencing emotions exist in cultures across the world. The word lunatic itself comes from the Latin word luna, meaning moon. For a long time, scientists dismissed these ideas as myths, but modern research has started to explore something interesting. Some studies suggest that lunar cycles may influence subtle biological rhythms in humans, not dramatically, but measurably. Researchers studying sleep patterns have found that during certain lunar phases, people sometimes experience slightly shorter sleep cycles, increased nighttime wakefulness, changes in melatonin production. These effects are small. Many people don't notice them at all, but across millions of people, even tiny biological shifts can influence collective behavior. During extreme lunar events like a total lunar eclipse, some people report unusual experiences, more vivid dreams, a feeling of restlessness during the night, a strange sense of heightened awareness. For most individuals, these sensations pass quickly, but when large populations experience subtle changes in sleep and emotional balance, human systems can react in unexpected ways. Because human civilization runs on decision-making, markets respond to confidence, governments respond to pressure, crowds respond to emotion, and emotions can spread faster than logic. During moments when the world already feels tense, economic uncertainty, political conflicts, environmental stress, even small psychological shifts can amplify reactions. Investors become more cautious, crowds become more reactive, leaders become more decisive, sometimes too decisive, and decisions made under pressure can ripple outward through global systems. A single policy announcement can trigger market turbulence. A misinterpreted signal between nations can escalate diplomatic tensions. A rumor can spread through social media faster than facts can catch up. None of these reactions require a cosmic cause. They simply require a moment when human attention becomes heightened. And events like the blood moon do something powerful. They focus attention. For one night, millions of people look up at the sky and think about something larger than themselves. They feel a sense of mystery, a sense of cosmic scale. And when humans confront that kind of vastness, emotions tend to intensify. Some people feel awe, others feel curiosity, and some feel a quiet sense of unease. Those emotions don't disappear the moment the eclipse ends. They linger, subtly influencing how people perceive events during the days that follow, which means that during those 72 hours, The planet isn't the only system adjusting. Human psychology is adjusting too. And in a civilization as interconnected as ours, human reactions can move systems faster than any natural force. Markets can rise or fall in minutes. Global communication spreads information instantly. Political decisions can affect millions of lives overnight. Sometimes the most powerful changes in history begin not with earthquakes or storms, but with human decisions made during moments of heightened tension. That's the deeper reason researchers pay attention to the days following major celestial events. Not because the sky is controlling the planet, but because these moments remind humanity of something important. We live inside a vast system of cycles, astronomical cycles, planetary cycles, economic cycles, psychological cycles. And occasionally, those cycles overlap. When they do, the world can feel slightly unstable for a brief moment. Not dangerous, but sensitive. A moment when small choices can produce large consequences, which leads to the most important realization of all. Because the blood moon itself isn't the real event. It's not the shadow. It's not the red color. It's not the spectacle in the sky. The blood moon is simply the clock, a signal that a rare alignment has just passed, and that for a brief window of time afterward, the world may be paying just a little more attention than usual. What happens during those hours depends entirely on us. The blood moon doesn't change the future. It doesn't control the planet. It doesn't decide what will happen next. What it does is something far more powerful. It reminds us how the universe actually works. Everything moves in cycles. The moon moves through its phases. The oceans rise and fall with tides. The planet shifts through seasons. Even the stars follow patterns that repeat over thousands of years. Cycles are the quiet rhythm of the universe. Expansion and contraction, calm and pressure, balance and release. And humanity is not separate from those cycles. Human civilization moves through them too. Economic booms and crashes, periods of peace followed by moments of tension, innovation followed by disruption. History itself is not a straight line, it's a pattern. Moments of stability, moments of pressure, moments when everything feels like it's holding its breath, and then moments when everything suddenly changes. Those are the moments when cycles collide, when natural systems, human decisions, and global tensions all intersect at the same time. When that happens, history has a strange habit of accelerating. Events that might have taken years suddenly unfold in weeks. Decisions that once seemed impossible suddenly happen overnight. The world can change faster than anyone expected. But here's the part most people misunderstand. The universe does not decide those outcomes. The moon doesn't make the choices. The sky doesn't write the future. We do. Human decisions shape the direction of history. Every market move, every political decision, every action taken during moments of uncertainty. Those choices ripple outward across the world, and during times of tension, small choices can create enormous consequences. That's the deeper meaning behind events like the blood moon. Not fear, not prophecy, but awareness. A reminder that we live inside a system far larger than ourselves. A reminder that moments of alignment happen, both in the sky and in human history. And when those moments arrive, what happens next depends entirely on how humanity responds. So the next time the moon slowly turns red and the sky glows with that strange crimson light, don't just admire the spectacle. Don't just take a photo and scroll past it. Pause for a moment and ask a bigger question. What will happen in the 72 hours after? Because sometimes the most important events in history don't happen during the moment everyone is watching. They happen quietly in the hours that follow. Right after the sky returns to normal, right after the world thinks the event is over, right after everyone stops looking up,